Stop burning tokens. This is how you build AI agents that think, triage, and save you money. If your current agent relies solely on the most powerful model for every task, simple classification, complex reasoning, or a quick summary, you are paying the premium price for every single action. And that scales linearly into unsustainable operational costs. The core problem isn't the model, it's the lack of intelligence in the workflow. You are using a scalpel for a hammer job, and you're paying GPT for prices for the swing. The solution is the introduction of the model router, a dynamic middleware layer that doesn't just pass requests to an LLM, it intelligently decides which LLM should receive the request. This router transforms your agent from a monolithic black box into a distributed cognitive ecosystem, allowing you to match complexity to computational resource. Think of it as a highly sophisticated air traffic controller for your prompts. It assesses the incoming task vector and calculates the optimal path to execution. The decision matrix is based on three primary factors: task complexity, required context depth, and tolerance for latency. Low-complexity tasks, like sentiment analysis or simple entity extraction, should be routed immediately to a low-cost, high-throughput model like GPT 3.5 Turbo. If the task requires synthesis across multiple documents or novel problem-solving, that's when you escalate to the premium resources of GPT-4. And for the truly resource-constrained environments, local or fine-tuned smaller models can handle highly specific, repetitive tasks without any external API calls. But how does the router make that decision? This is where the implementation detail matters most. You need a pre-filter module. This module analyzes the prompt's intent using a small, fast classifier model. It doesn't need to be GPT-4, a well-tuned BERT, or even a simple prompt engineering chain suffices. That score dictates the routing threshold. If complexity exceeds X, you pay for GPT-4. If it's below Y, you save with GPT's 3.5. This is where the latency check becomes critical. If a low-cost model times out or enters an infinite loop, the router must have a failsafe to escalate that task. This retry escalation chain is your reliability insurance. It ensures that a momentary failure doesn't derail the entire user experience. Let's look at a simplified pseudocode structure for this decision point. This is the heart of your orchestrator. We define a router function that accepts the prompt and executes a rapid classification check before committing to an expensive call. The classifier returns a score. We use defined thresholds to immediately branch into the correct, most efficient executor. If the task is marked high complexity, we pass it to GPT-4. If low, we use the cost-effective alternative. And crucially, you must track the execution path. Every token spent, every millisecond elapsed, needs to be logged against this routing decision. This observability loop allows you to refine your thresholds. You find the sweet spot where GPT 3.5 handles 80% of the volume without sacrificing quality. Beyond simple routing, consider chaining. A task might need a quick draft from GPT 3.5, followed by a refinement loop using GPT-4 on the output. This multi-stage approach is the ultimate token efficiency move. You are using models cooperatively, not competitively. The model router doesn't just save money, it radically improves the perceived speed and reliability of your entire AI product. Go beyond the single prompt. Build the cognitive infrastructure that allows your agents to manage their own existence and optimize their own resources. If this architectural breakdown helped you move past the sandbox phase and into production scaling, hit subscribe. We dive deeper into observability patterns next week.